In this video we're going to talk about titrations. And what a titration allows us to do is to use a solution where we know the concentration to figure out the concentration of something that we don't know. For example, in this titration we're going to look at this sample of hydrochloric acid. It's a 20 milliliter sample and I don't know its molarity. This right here in this burette, which is basically a graduated container where you can measure the volume dispensed, has a sodium hydroxide solution in it with a concentration of 0.5 moles per liter. So if I know how much of this I add and I know the concentration, I can figure out how many moles of the sodium hydroxide I had to add to this solution to neutralize it. Now, what I'm going to add to the hydrochloric acid is something called phenolphthalein, and it's an acid-base indicator which gives us an endpoint where it's going to change color. I only have to put a few drops in. And it's going to change color when the solution goes from being acidic to basic. So, since it's a hydrochloric acid in here, the pH is definitely less than 7. I don't know the exact pH, but it's definitely way less than 7. As I add the sodium hydroxide to it, it's going to neutralize that acid in order to produce water and a salt through a double displacement reaction that results in this case in the production of water and sodium chloride. But once all of the hydrochloric acid gets neutralized and there's no more HCl in the solution, any additional base that I add is going to make the pH spike. And when the pH goes north of 7, in this case the phenolphthalein will actually change its color at a pH of about 8 to 8.5, I'll know that I've neutralized all the acid and I'll stop there, and then I can do some stoichiometry to figure out how many moles of hydrochloric acid were in the solution and then use its initial volume of 20 milliliters in order to determine the concentration. So, let's start this off. I'm going to add slowly some sodium hydroxide solution. And you can see that it starts to turn a little bit pink in small regions as I add it until I distribute the sodium hydroxide throughout the solution. As I do that, the color goes away as the sodium hydroxide or the basic regions get consumed by the acid that's already in there. I know that the initial volume on this was 23.6 milliliters, and then we'll see what the final volume is when I've reached the end point, where I've neutralized the acid, and we have a color change. And then we'll use that to stoichiometrically calculate the concentration of the hydrochloric acid. Notice I'm adding really small, actually that's not perfect, but it's okay. You really want a fainter pink than this. But at this point, I've definitely reached my end point. I've neutralized all the acid. So right now, I can look in the burette, and I can see that I've reached a volume of 30.70 milliliters of the sodium hydroxide. So it went from being 23.6, and it went down to a reading of 30.7. Now what we're looking at here, I know it doesn't really make sense to you that it's going down in volume, but it starts at 0 and works its way down. And if you started at 0, it would tell you the volume dispensed. But really all you need to know is the difference between these two. And when you look at that, you can see that this is a volume of 7.10 milliliters of sodium hydroxide solution that I added. Since I know that the molarity of it is 0.5 moles per liter, we can then do some stoichiometry to figure out how many moles of hydrochloric acid we had, and then calculate the molarity. Pause. All right, so since we add 0.00710 liters of sodium hydroxide, which is what 7.1 mils is, and we know that the concentration of the sodium hydroxide solution was 0.50 moles of sodium hydroxide per liter, we could figure out that we used 0.00355 moles of the sodium hydroxide. Since that reacts in a 1-to-1 ratio with the hydrochloric acid, we can then say that that's going to be equal to the number of moles of hydrochloric acid that we had in the solution. And since the molarity is the number of moles of the solute per liter of solution, and we know that we had 20 mils, or 0.0200 liters, we divide the number of moles by that number of liters, and we can see that the hydrochloric acid had a concentration of 0.178 moles per liter. So again, a titration. We use a solution where we know the concentration to determine the concentration of an unknown through stoichiometry.